Continue with question 4 of our prelim paper, the chemistry paper of 2022. Question 4 states, start on a new page. Most organic compounds can undergo different reactions to produce a variety of compounds. Some incomplete reactions are represented below. So now if you look at this diagram, there's quite of A, B, C, D. There's many reactions taking place. So just without looking at the questions, let's just see if we can see something that's making sense to us, or just to get an idea in your mind what is happening here. So let's just see, secondary alcohol, there's an alcohol and becomes propene, so an alcohol becoming propene, propene becoming an alcohol, propene plus hydrogen bromide, it forms 2 bromopropane. So what's happening here, the hydrogen bromide is added to propene, that's an addition reaction. You got propane plus HBr becoming 2 bromopropane. Then you can see there's a basically the bromine is added to the propane. You got hydrogenation, and then the bromopropane becoming an alcohol. So the bromine is removed and the OH is put in there. So just some idea. You should look at the diagram and see a little bit of, make a little bit sense of what you can before looking at the questions. All right. So looking at the questions now, consider reaction A. Yes, reaction A. Secondary alcohol. So you have an alcohol, and then what type of reaction is taking place in A? So you got a secondary alcohol, maybe there's a OH attachment there, and it's becoming propene. So the OH group is removed, and then you're getting a double bond that is formed. So basically, what's happening? The single bond is removed, OH is removed, and you're forming a double bond. So what are you doing? Getting rid of the alcohol is dehydration. It could also be elimination, because you forming from a single bond, you're going into a double bond. So we can say elimination. I'll just write down our question. Question 4.1, we can say it's elimination or dehydration. Nah? You can choose one. Okay, next question will be 4.2. Let's look at the question. Reaction B, okay, represents hydration. Reaction B, the propene, you're adding water so that you get an alcohol. Define the hydration reaction, right? So basically, what is hydration? As we just said, the double bond is you adding water. So you're adding water. So hydration is the addition of water. 4.2.1. 4.2.1. The addition of water. 4.2.2. The question is, define and name the formula of the catalyst used in this reaction. So lots of times the catalyst used in this reaction is sulfuric acid. 4.2.2 sulfuric acid, so H2SO4. 4.3. During reaction C, where's reaction C now? Propene is becoming 2 bromopropane. Okay, so what is happening there? Again, an addition reaction is taking place. Write down 2 conditions of this reaction. So we can see you cannot add water, alright, and then you must add a strong acid as a catalyst. You need to know that from your theory. So we can say 4.3.1. We can say no water must be present, and we can say strong acid as a catalyst. Use a strong acid like H2SO4 as a catalyst. Okay, we can say that 4.3.1. Use structural formula and write down the balance equation for this reaction C, right? So we got propene plus HBr. Let's write that down. 4.3.2. So we got propene Alright, so it's prop 1 in. We've got a double bond there, we'll have hydrogen there, hydrogen there. We see the carbons. You can have more than 4 lines around a carbon, 4 bonds around the carbon, because by mistake we'll add another hydrogen here, which we cannot do, right? And then you're adding HBr to it, and then what's going to happen? The double bond will break. So here's the carbons. Let's just put this down. Carbon, carbon, carbon. And then the double bond will break, right? So the hydrogens, the carbon, the double bond will break. And then if this double bond breaks and it comes here, then there's another place for an attachment. And the rule that we know of is the bromine will attach to the carbon that has the least number of hydrogen attachments. The bromine will attach to the carbon that has the least number of hydrogen attachments. So the carbon at the end has 2 hydrogen, and the middle carbon is only attached to 1 hydrogen. So the bromine will attach to the carbon with the least hydrogen. So it will be here. So if we go on this side, we can say the bromine will be attached there. And the hydrogen from the HBr will be attached there. And then the other hydrogens will fit in place. Right, so that's 4.3.2. Use structural formula and write down the balance equation for this reaction. So that's the balance equation for the reaction. 4.4. Identify the type of reaction taking place at D and taking place at F. 4.4.1, 4.4.2. Okay, 4.4.1 and 4.4.2. 4.4.1, 4.4.2 at D and at F. Right, so let's look at our equation. At D, 4.4.1, D and F. At D, what's happening? We see the propane, and you basically becoming 2 bromopropane. So the propane stays the same, and then basically there's a substitution. The hydrogen goes out and the bromine goes in. So if you're not sure, you should write it out. Alright. I'm gonna try. Okay, let's write it out. Propane and 2 bromopropane. So in our mind, or if not on a page, write it out. 4.4.1. You don't need this. You can. It's just a substitution reaction, right? Let's write it down. But if you're not sure, you should work it out. Substitution reaction, right? So here's propane, what's it called? Propane and 2 bromopropane. Propane got 3 carbons. You got propane, it's got the hydrogens around it, and then it's becoming carbons are still there, and it's becoming bromopropane. That means the hydrogen is going out and the bromine is going in, and here's all H's around it. So you'll have to work that out so that we know what's happening, right? So if you look at the next question, 4.3.4.2, write down the name and the formula of the catalyst used. Oh no, 4.2.4.2 reaction F. So there you got bromopropane. Then you got 2 bromopropane and it's becoming an alcohol. So that the alcohol has an OH group. So the Br, the bromine on the second group is going out, and then the OH group is coming in. 4.4.2, and that will also be a substitution reaction. So let's just write it down and let's just see how we can. It will also be substitution reaction, right? So it will be the substitution reaction. Again, here now in our mind or on our side, if you don't know it, you write it on a page. You got bromopropane, you got your carbon, carbon, and carbon, and there's a bromine there, and you got your hydrogens all over, and then now it's becoming, the bromine is taken off, and then you're going to have your carbons with your hydrogens all over, and then instead of the bromine you're going to get the OH group being attached here. So because the OH group is being attached here, basically then you will know that it's also a substitution. The bromine is being substituted by the OH group. So that's how you will do it. Alright, let's see if there's more questions. 4.4.2, but 4.5. Reaction E is a hydration reaction. A hydrogenation reaction. Hydrogenation, right? So let's see, reaction E is a name 2 reaction conditions for this reaction. Okay, 4.5.1. E is hydrogenation reaction. So you must know your rules here, so that we can say there must be no water. It's hydrogenation, there must be no water, and there must be a catalyst, and the catalyst will be like a nickel catalyst, something like a nickel catalyst. There are others as well. 4.5.1. 4.5.1. No water present, and then we must say catalyst. Example, nickel. We must have a catalyst, right? Example, nickel catalyst. There may be others that you can use, but we're not going to go into them now. Maybe platinum, etc. Right? 4.5.1, 4.5.2. The next question is, this reaction is widely used in industry. Name one use of the hydrogenation in the food industry. So then you have propene and you got propane. It's hydrogenation. So the most common use is the manufacture of margarine. 4.5.2. The manufacture of okay, So that will be the answer for 4.5.2. Is that the end of the question? 14 marks? Yes. So here was an example where we looked at question 4 relating to the different reactions of organic chemistry. Let's see if we answered all the questions correctly. 4.1. Question 4, all the answers are done. We are fine. Alright, that's where we will stop. We'll do the next question soon.